Good day, my viewers. My name is Samuel Jude Ayodele, Smart Tutorial founder. Today we'll be looking at valency of elements. When you talk about valency is the combining power of an element, that is the ability of an element to attain octet state, which is the stable state. From group 1 to group 8 of the periodic table, the group 8 is the only stable group out of the 8 groups we have, while the other groups are unstable. All these unstable elements try to attain the octet state, that is to attain the stable state, by either losing electron or gaining electron, sometimes sharing of electrons. But today we are going to differentiate between what is valency and what is valence and what is valency. Valency is that measure or the power or the ability of each element to either lose or gain electron so as to be able to attain stable state, while the valence electron is the electron at the outermost shell of an element. I think you can still remember the KMNO shells. That is the 2888 arrangements, the electronic configurations of elements. So this electronic configuration, from the electronic configuration you can know if an element is stable. Group 1, 2, 3, they are melters and they are not stable, while the group 4 tends to act in such a way like melters and non-melters sometimes, depending on the elements they are reacting with, while the group 6 and 7, they are pure non-melters, and the group 8 or group 0, like I said earlier, they are stable. So the valency of group 0 or group 8 is 0. That is their valency. So we are going to the valence electron determines, we can use the valence electron to determine the valency of elements. We look at the illustration we have there. The illustrations is sodium. For sodium, we have this. Sodium has 11 electrons. That is the atomic number of sodium, which is the proton number, is 11 electron in the electronic configuration, which is 281. So it is more easier for sodium to lose one electron. It's more reasonable to lose one electron than seeking for 7 electrons. The same thing applies to chlorine. Chlorine is 287. It needs only 1 electron to become stable. You know, the octet state, 8 number at the back. So chlorine cannot forfeit his 7 electron. It only needs to look for another electron. Only 1 electron. So chlorine will rather gain electron than, if you look at sodium is 1 looking for 7. No, so sodium will rather lose the 1, while chlorine will either seek for 1 electron. The same thing applies to nitrogen. Nitrogen is 258, 5, either to lose the 5 electron or to gain 3. It's more reasonable to gain 3 electron. That is, all this tends to determines the valency of these elements. That is, the valency of sodium is 1, for chlorine 7, and for nitrogen is 3. So how do we use the valency to determine the compounds of elements? We can use the valency to determine the compounds of elements by the 4 steps. The first step, which is you have to know the name of what you want to form. For example, you want to form a particular compound. What are the elements that make up the compound? That is, you need to identify the elements. Then you get the valency, like I've explained earlier. Then you break it, the valency, into smaller ratio. You look at the ratio of the elements, the ratio of the valency of those elements. Then you cross multiply, like I've as well explained on the board. So all this is they are just basis under valency. There are still a lot more on it, but we just give this for free so that individual can learn one or two things from what valence from what valency is. So we have aluminium oxide from aluminium and oxygen. The same thing, sodium chloride from sodium and chlorine. So the valency is 1 and 1. If you cross multiply, you get 1 1. That is, if you remember in our previous class, we have anything when you come across 1, you just neglect it. That is, so it's still the same thing as nothing is there. Like 1s is still the same thing as x. So the same thing applies here. So there's no need of putting the 1 1. If you put it there, no problem, but it doesn't make your work look good. So as students, you need to know how to write this formula very well for all compounds. You need to know. You can practice on your own. If you are confused, maybe someone tell you calcium chloride, you don't know, maybe CaCl or CaCl2, just try this, you get the right answer. So we have 4 examples looking at the video. The calcium chloride and then the hydrogen sulfide make up the other 4 examples. So we'll be rounding up on this just because we understand that so many of us are managing our data, and we have different programs available for those that can manage their monthly data to meet up with the months. We understand the nature of our country, so we have other medium that will not consume much data. So we hope that you can contact us for your private lectures or private tutorial, private lesson in your various subjects. Will give you the best. These are just the basis. There are still a lot of things that we can use valency for in chemistry. Linking of valency to oxidation number, from oxidation number to form compounds, to form as in other topics. But for that, which you get in messages on our Facebook. We still have smart tutorial there. It's for free. You can get it there free. But to go deeper in all these subjects, just message us, and the terms and conditions will be met. Then we'll give you our best. Our service is efficient. You don't need to be scared of you don't have much data. We understand the nature, and we have a way of making your small data to be enough for the whole month for you. And we also understand the nature of the electricity. That one is not, they are not problem. We have a well package for different people. If you have enough data, no problem. If you don't have enough data, just have. That is just what we are after. Then we'll give you a bundle that will satisfy you. And our service is efficient and very impactful. Thanks for watching again. This is Samuel Dino, the founder of Smart Tutorial. Enjoy your day. Just comment, share with neighbors, and also remember to like and subscribe to our channel on YouTube, Samuel Dino. Thanks for watching.